Let's continue with our inventory library. Hello everyone, this is Ali Raza. Welcome to the Mentor Code Lab. When I was finishing the Jiralib, I didn't look into different implementations that Turtiworty had. I previously had a library that was really close to what he was doing. I had seen him with his live videos and live streams, and I didn't copy paste his code, but I tried to implement my own library just to learn things better. However, now that I look at his own mod and compare my own library with his, I noticed that he uses an extra layer of abstraction and sometimes a better approach in the same stuff. So I have to go back into Jiralib and add one more method and add one more class. Keep in mind, this will force me to delete the artifact and everything else just because I want to keep that daemon version number consistent. I don't want to upgrade that version numbering whatsoever right now. This is not a finished product right now, so I will just stick to that version. Actually, I could start with 1.0.0, but I'm not going to roll back because I'm not sure if anyone had ever used the previous version of the library. So the thing that we want to add here is a class. Now, take a look. What Turtiworty is doing in his Industeria mod is wrapping things around each other. So the idea here is that we want a storage that is sided, so we can have a storage that is available on one side of the block and is not available on the other sides of the block. The thing is that he is naming his classes starting with wrapped. So wrapped storage, wrapped inventory storage holder, stuff like that. However, in my opinion, using a wrapped storage name is not convenient because honestly, these are not the storages themselves, not at all. They are sort of connectors between the storages and your block entity. So they are this gadget that you put in your device and opens a whole bunch of sockets or sockets, whatever its pronunciation, and lets you connect different things to that device. They are not the extensions themselves. So for example, you have a socket and you can insert a cartridge for the inventory. Okay, the socket and its gadget is not the inventory itself. And calling it wrapped inventory, for example, that makes me confused. I will change the name to storage connector. This is the base class. Now, it asks for a generic and it implements the INBT serializable of the NBT list. Now we can implement the methods for the write NBT and read NBT. At the same time, we want a protected final list of the T, and we call it storages equals to new array list with the mapped direction dot values dot length. So we make sure that each one of these connectors has enough storages for different directions. Means that north, east, south, west, top, down, and none. So we have 7 slots in each connector for the storage itself. And then we have a protected final map of the mapped direction with the type, and we call it sided storage map or sided map, whatever. And this one is a new hash map, again with this size. So we are limiting the size of the list and the hash map. Now we want to have few different methods. So public void add storage. The storage is the type of the T, and this means that we are not providing any direction. So we call the storage and we go with mapped direction dot none. Now we don't have this overload. So public void add storage with T as the storage and mapped direction. This one says this dot storages dot add the storage. Also, this dot sided map dot put the direction comma storage. Now compare my code to what Turtiworty has, and this is why I added that map to storage. He has to check the null. Each time it's null, it has to add it to every direction, and then if it's not null, it uses the direction. So using the none simplifies this logic a lot, not only for when we put this in the storage, but at the same time when we take it out of the storage. Okay, then we want a public list of T, and we call it get the storages. We return this dot storages. We want a public map of mapped direction comma T. We call it get sided map. We return this dot sided map. Then we have the public T get storage with the mapped direction side, and we simply return this dot sided map dot get the side. Now again, take a look at his logic. He has to check if it's it's null. If this is null, then he will return the first. If otherwise, he returns the side because he's using the default direction. Now I will change it and I will give him an overload that accepts the direction, but here we want, yes, direction from Minecraft, thank you. We want mapped direction dot from direction side, and that solves that. Now, at the same time, we may want to get from the index. So get the storage by the int index, because we don't know the side or whatever, but we know that this was the first one that we added to the list, okay? So we say return this.storages.get at the index. Now here's the thing. I think I had something on top of this because I think he dissected part of his code into this high-level class, and I didn't. So let me take a look at my own wrapped inventory storage into my own storage class and see what we have. Okay, we have the add inventory. Oh, here we go. I have some helper methods, and these are related to inventories actually. For example, add sync inventory, get inventories, and then sided map. Okay, here's one thing that I want. We return a single slot storage of the T, I think. We call it get slot with the int slot index and map the direction. So what we do, we return the get storage from that direction. Then from this one, we get, oh, we don't get the slot index. Okay, here's the thing. The T, okay, this can't happen here. Okay, it needs to happen inside the inventory stuff itself. Yeah, that's the whole thing. Okay, I compared the things, and read and write NPT. We don't do anything here because this class is again an abstract. So right now I have to delete the Maven artifact, delete my downloaded artifacts on the hard drive, and republish and re-download. Fun stuff. I will come back when it's done. Okay, finally finished that. Now we go back to our inventory structure and we can continue. Now that we have that connector, storage connector, we can add more storages to our system. So before doing that, actually, I want to add some slots. Some of them may be provided by 3040, some of them may not. I honestly don't remember. So here's the package called slot. We will have a Java class called predicate slot. This extends the slot. I think this one was developed by 3040. So create constructor, and inside here we will have a private final predicate, and that is the item stack. We call this one predicate. The constructor will ask for the predicate at the end. So predicate of the item stack, we call it predicate. After the super, we say this dot predicate equals to predicate. We have an overload for this. We'll remove that predicate part, and we call ourselves, instead of creating a predicate, we say inventory dot colon can insert, and instead of inventory, actually we want a simple inventory. These two are different. One is an interface, the other one is a class. This one was the interface, this one is a class. The class has the can insert, we can use that. And finally, we want to override our can insert. We will say this dot predicate dot test the stack, and that's it. So we have a slot that we can add to our inventories, especially on the screen handlers later, and we can say that, hey, this slot will only accept this type of item stack because we are adding that predicate. Now on top of this, we can have many more things like the tagged slot. Now these ones, I'm not sure if they were produced by Tutti. I think these guys are mine. So tag the slot, extend the predicate slot. We will add the constructor. However, instead of having a predicate, we want a tag key of type item. Remember, we are inside inventory library, so we are working with items called the tag key, and here we say we want an item stack lambda. All we are checking that item stack that is in the tag key. So that's our predicate right there. And basically now we have a slot that can accept any item that is inside a single tag. Then we have not tagged the slot. Basically, it extends again the predicate slot. It's almost exactly identical to other one. So we ask for a tag key of item. We call it tag key. And another tag key of item, we call this blacklist tags, or I don't know, limit limit tag key. Why not? So for the predicate, we send in item stack into a lambda, but here we say that item stack dot is in the tag key and not item stack dot is in limited tag key. As simple as that. Now we have more flexibility. We want, for example, I don't know, swords, and those swords that are not in my special tag list, like, I don't know, OP list. So something like that, much more flexibility, and I like having flexibility. Now we have limited tag slot, so limited tag slot, and this guy is again extending the predicate slot. So create the constructor, and instead of the predicate, we actually want the same thing that we had on not tag, like so. However, here we are behaving, actually, wait a second, these two are identical to each other. Not tag the slot. Oh, I'm derping. Oh, okay. We have to copy this, and this is the limit one. The not tag slot is exactly the reverse of tag slot. We don't have this, but it shouldn't be in the tag list. I derped a little bit there. So the last one of the slots is the output. So we have an output slot. The output slot again extends the predicate slot. So you can imagine how powerful that predicate slot became. And all we are doing is saying that, hey, the item stack goes into the lambda, but lambda returns false by default. So this slot will not accept any item by the user. And that's it. Now, I think the predicate slot and output slot was developed by 3040. So let me get this guy, because this is for sure from his repository, and these are not. So the predicate slot is his, and why do I see this? The output slot is from his repository, I think, but not tagged, and limited tags, those are mine. Okay, finally, I can free my brain to look into the last one of the classes and actually compare it to my own one and add whatever we need to whenever we need to. So as I said, he calls everything. Actually, why are you out of there? You go there. He calls everything he has as wrapped, but I see them as connectors. So I will create the name as item inventory connector. Actually, let's call it JInventory connector, inventory connector. Why not? Keep it simple. And this one is T extends simple inventory. Now, this extends from our storage connector, and the type here is inventory storage. Okay, this will force us to implement some methods, write and read NVTs. However, before that, we will have more than few stuff. So private final list of T, that is simple inventory, by the way, and we call it inventories equals to new array list of T, not T, new array list is equals to new array list. Now, here's what confuses me. He had written the connectors like so. So he has the storages, and this is the list. Why is he re-implementing it? I think he forgot that he has it already. Let's see. He had a private final list of pair of, okay, this is decided inventories. Again, god damn it, we have it. Map direction, and this is a map. He wants a list of a pair as sided inventories. I seriously don't understand this guy. Means that he wants more than what he provided by the storage connector. Basically, he's going for a pair of the map direction and the type, and then a list of that on top. No, not for me. Okay, private final combined storage of item variant and inventory storage, and we call it combined storage equals to new combined storage, and we call this dot storages. Okay, so far so good. Now, I will keep in mind that he is using inventories everywhere, but I should be able to convert it back to the storage, and the sided inventories is just being retrieved. Okay, so let's start. I'm looking at both solutions, mine and his. Basically, this is what he had, and this is what I had. I have a list of simple inventories, list of inventory storages, and stuff like that. Then the combined storage and sided storages for both of them. So I will compare these two on the second monitor, and if you notice that I'm pausing between the words, is because I'm doing a comparison at the back end. So we want a public void add inventory that accepts a not null T inventory. And by the way, didn't you have it here? Add a storage. And you're accepting the T here is simple inventory. So that's the same stuff, for God's sake. Now, oh, wait a minute. He's doing it this way. He says that when I want to add an inventory, he adds it to the inventories list. He adds it as a pair to this guy. And then he finds a storage, inventory storage that of inventory and the side. And he then adds the storage by default. Why is he doing it? Oh, we are asking for simple inventories, are we not? Yeah. And we are typecasting to inventory storage. Oh, I see now. Okay, let's add them. Let's have what he has on top, and this one will be mapped direction, not yours, sorry, and pair. Okay, then we add the inventory. So I will copy from his code. We go with add inventory and inventory null. We don't need null now. We will say mapped direction dot none. And finally, this is where his storage is coming to play from our connector. So mapped direction side. Okay, and this one is a direction. So we say mapped direction dot to direction side. That will solve that for the inventory storage. And that's basically it. Now, the reason this is happening is that here we are making the list. Actually, wait a minute. We are asking for an inventory storage. Now, inventory storage is different from simple inventory. The simple inventory is implementing the inventory and recipe input. The inventory storage is an interface that gets the slot count, stuff like that. Now, why we are not using this? Because we can't get the slot and count and stuff like that. Okay, so he is giving himself the combination of both solutions provided by Minecraft. Smart guy, I told you. Basically, what he's doing is that he is asking for inventories and then he is binding them with the concept of the inventory storage. So when he adds the storage, basically he's calling here. So he will put it inside the map and the storage. And honestly, I'm not sure if I'm happy with this guy here. There is a chance that a user can screw this up. Actually, no, there is no chance of screwing it up because this is private, not protected. Okay, good. So let's go forward. We have another add inventory that asks for a supplier can insert and the supplier can extract. He is calling another overload, and instead of null, it should be map direction.none. See how different this is? It's this guy. And again, instead of direction, we are using map direction. So that's that. And again, here we have to call mapped direction dot to direction decide. Okay, let's see what did happen. So far, we added a simple inventory, and then on the main connector, we have the inventory storage of that simple inventory. Okay, here. Then we add overloads that we accept a simple inventory. We can insert and can extract. And now we do this. We add the inventory, we add the side, but when we want a storage to be added as the inventory storage, we use predicate inventory storage. This will create the storage of inventory storage, and then as the predicate, you remember that we can add the can insert and can extract inside here. We did write it in, I think, previous episode, I'm not sure, but this is how we are using it now. Okay, so we can add a simple inventory that can insert and can extract based on the suppliers that we want. We will add more overloads, and these are actually easy, so let's add all of them. And God, these are mapped directions, please. Okay, so the add insert only, we are adding a simple inventory on the side, but the can insert is true. We add insert only inventory with the supplier can insert. So we use the can insert, but we send the can extract to be false. We add the add extract only, and here we can't insert, but we can extract. And finally, we add the supplier. So again, we can't insert, but we use the supplier. Okay, and all of these are calling this overload. Let's continue. Public a list of T, and we call it get inventories. This will return inventories, and that is why I said people can't mess things up. These are private. So public combine the storage of item variant and inventory storage. Get combine the storage. We return we combine the storage. Then we have public that is nullable. We return the T, and we can say get inventory with the int index. Here we say return this dot inventories dot get at index. The other one will be the same get inventory override, but we will use mapped direction. And here we say inventories dot get this dot storages dot index of the get storage on the side, and I should call it side, not the direction. Okay, the other one would be the same overload, but I will use the direction from Minecraft library. So direction, and basically that's it, because the get storage has an overload that is using the direction. And now we have more methods to get the stacks. Okay, before I proceed forward with the rest of the methods, I want to make sure that you understand what we have right now. The thing that we have is a complex system that combines any type of storage with the inventory of the storage. So for example, we can have an inventory connector of type, and this type can be anything. For example, our synced simple inventory or recipe inventory, predicate inventory, whatever. Okay, it should be an extension of the simple inventory, and let's call it test. And now I'm not going to instantiate it, but now I have test dot. And let's start from top to bottom and talk about different methods. We can actually add inventories, as you see, add extract only, add insert only, add inventories, or we can add a storage, and then this will not be available to you. It's showing up because we are inside the inventory connector, so it's a private or protected field. It won't be available outside of the class. But we have get combine, the storage, get inventories, get inventory, and then read NBT and write NBT. Also, I think we will have the storages, I'm not sure. But let's see. If I say that I want to get the combined storage, what do I get from that is that I can get parts, like that's a list of inventory storages. I can see if it's supporting the extraction or insertion, and I can extract or I can insert into the storage. If I get the inventory, okay, well, list of inventories is just like having a list and then going to select something inside the list. But let's say that I want the inventory indexed 0, and now I have access to an inventory. So I can check to add a listener, add a stack, or I can check if I can insert the item stack, if I can transfer something, if the inventory contains anything that we need. We get the count of any item in the inventory, or get a block entity out of the inventory, getting the max count of an item stack, getting a stack in a slot. For example, I know that slot index 0 is our input, so I get the stack there. I can check if the item stack is valid for the slot or not, if the inventory is empty or not, call the open and close on the inventory, read the inventory, remove an item with a count, or remove a stack with amount or without the amount, set the stack in a slot, sync the inventory, and that's it. So basically we can handle everything we need to manipulate our inventories. On the other hand, we have get the storages. Now let's get the storage index 0. This thing is different because now we are not working with an inventory, but we are working with the storage. So now we can extract from the storage, we can insert into the storage, and we can get all the iterators that are not empty, get all the views that are not empty. For example, if I get all the views, we can iterate through them and do whatever we need. We can check if it supports insertion and extraction. This will again handle anything that we need. If you recall, the inventory itself is good when you want to manipulate the slots and item stacks in the slot. The storage is good when you want to transfer into and transfer out of the inventory. And this is what we already have. Now, on top of these, I want to add some useful methods. For example, I can get the storage and out of that storage get a slot. However, I want to directly have the ability. So I will say public that is nullable returns a single slot storage of type, I'm not sure if it's item variant or not. It's inventory connector. No, item variant. And this will be get slot. Here we will add an integer for slot index and a mapped direction for the site. We will say that, hey, return this dot get storages, or actually get the storage for the site, then get the slot from slot index. So you see that I'm chaining some commands here just to make my life easier. As I said, I'm a lazy guy, and every now and then I like to have easier way of accessing things. Then I have another overload. So let's do this. I will select all of that, and instead of site, I will say int index. And here I'm getting it from the index on the storage. And finally, want another overload for the direction instead of the mapped direction, and this should work from scratch. I will have a list of the slots, although I'm not sure if I need it or not. But as I said, I'm developing an API, and when you're developing an API, you don't know how people will use it. So it will be a single slot storage list of item variant. Basically, we were getting one slot. Now we are retrieving all the slots. So get slots for the mapped direction. We call it side. And here you will say return this dot get storages, or get storage actually for the side. And out of that, we call get slots. And that's it. Again, I want two overloads for that. One is accepting the direction from Minecraft. And finally, another one is accepting an int from the index. And here I use the int index. These get slot and get slots are some methods that I added myself to the whole system. And also the code provided by JInventory now has some extra methods. And I'm just double checking that. Yeah, that's it. I have covered everything from my own version here. So I will say public returns @ not null, a list of item stack, and we call it get stacks. This will flatten the whole mapped inventory inside of one list and return it. This is all the stacks inside this connector. So we have a list of item stack. We call it stacks equals to a new array list. Then we go for a for loop. We accept t inventory inside this dot inventories and another loop for int I equals 0, I is smaller than inventory dot size I plus plus, and finally we say stacks dot add the inventory dot get stack at index I. Finally, at the very end, we return stacks. And I'm not using curly braces because these are single line of codes. Basically, we are nesting this section one after another, and that will work. Then we have a method called public void check size and compare to size. Basically, we are checking and comparing our own size to the given size. We say if this dot inventories dot stream dot map the inventory from net Minecraft inventory colon size dot reduce 0 comma integer colon sum does not equals to size. If basically the size of the things inside the inventory is not equal to the questioned number, then we throw a new illegal argument exception. We say size of inventories does not match the size provided. Here we add the size that we provided. Although I think we can make things a little bit more useful and we cut it, we say int inv size for the inventory size equals to that, and then we say inv size here, and finally we make the inv size plus something like / plus size. And what's your problem here? It's capital S. Okay, so now we know this was the number, this is the one that we are comparing to, so that's that code. The next method after check size is to call two different events for onOpen and onClose. So we say public void onOpen, and here we need a not null player entity. We call it player. And by the way, if you notice that I don't have IntelliSense, the reason is that I did restart my project and removed every Gradle project from the list. And right now, you see that my Jiralib is there, but I didn't refresh the dependencies for the Jiralib. So I need to push it into Maven, and then I need to add the JInventory to the list and resync the Gradle. So right now I'm working on a project that does not exist in Gradle. And there is a reason for that, but I will talk about that reason in the next video. Many things happened in the Jiralib, and I will talk about them and walk you through each one of them in future episodes. But right now, I want to finish this inventory connector and anything related to the JInventory. Now, for the onOpen, we look into this .inventories. We could go for a for loop, but I can use it for each inventory goes into, then because the inventory here would be a list of T, and we don't know what is the T. Actually, it's a simple inventory. So I should be able to directly say that inventory dot on open by the player. And I don't need to do the thing that Copilot suggested to me, because that was GitHub Copilot that suggested the code. I know that, okay, I'm inventory, and any inventory has that on open. Be careful about the typos here. The same thing is the unclose, and Copilot is smart enough that he knows I wrote this code. So when I'm going for unclose, it's the unclose method here. Okay, then I have another method, and that is public void drop content. Now this will happen when you break a block with an inventory. Not null word, that is the word, not null block pose, that's the position of the block. And again, we go for this dot inventories dot for each, and I will do that, and I will remove every lambda here. I don't need that. Now for the inventories, all I say item scatterer dot spawn at the word and the position, the content of the inventory, and that's it. Then I will have get recipe inventory. So public that returns a recipe simple inventory, get recipe inventory. We return a new recipe simple inventory, but it's wrong here. Get stacks dot to array new item stacks of 0. That's the correct code for you right there. Then we have a public that returns a list of pair of mapped direction and T, and that is get sided inventories, return this dot sided inventories. All I need to make sure is that it's this guy. So I will, because I don't have IntelliSense, I will copy it and I will paste it just to make sure that I don't have any typos there. Finally, we have the write NBT and read NBT, and these things are changed in the latest versions, so we may have to work around. But we say var NBT equals to new NBT list, and at the end we will return that NBT. In the middle, we will go with this dot inventories dot for each, and I will remove everything in between the lambda. I will move this curly brace at the end, and I will say var inventory NBT equals to new NBT compound. And because I know that it's the type of NBT compound, I will just use that here instead of var. I don't like using the var that much, so we say NBT dot add, and here we get inventories dot write NBT for the inventory NBT, then inventory dot get held stacks, and then the registry lookup that we have on top. I'm not sure if with the new version of NBT stuff inside Minecraft this will work or not, because we are using inventories, and if we go back to the blog, we see that when we have NBT compound and we would get an int or anything, or here's the decoding for the codec, I don't know, this may work or this may not work based on the changes that happened inside the NBT system. But for sure, when we import our project again, we will see if that is the case or not, if this will work or not actually. So the read NBT finally is, we say for, actually let's see, how can I make it? Yeah, for int I equals 0 and I is smaller than NBT size I plus plus, we want to say var inventory NBT equals to NBT.get compound at X. Let's close that curly brace. And here we say simple inventory, and we call it inventory, equals to this dot inventories dot get at I. So we have the inventory, and by the way, as I said, this should be NBT compound. Now that we have the inventory, we will say inventories dot read NBT from the inventory NBT with the get held stacks with the registry lookup. I'm not sure if this will work, because all we were doing, we were using inventories class and read and write NBTs from there. Hopefully, because we are using something internal and the way they change the stuff, this will still work. I'm not sure. But right now we have finished the inventory connector, and I will not load the solution yet because we have to cover more stuff inside the JInventory, and then we will have to talk about the Jiralib, and then we can import the JInventory in the solution and reference the Jiralib, because Jiralib had changed a lot and I need to talk about it. But that should wait for another video. Actually, I think I will go back to Jiralib and cover the changes because I want to have intelligence. I want to make sure that this is working properly before I move forward inside the JInventory and cover more. So in the next video, we will go back to Jiralib and talk about the changes that had happened in Jiralib between the pause, because when I paused the video and came back, near 2 days has passed and I was working on Jiralib first. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.